All right, let's go on to section 9.4. This one's called equations with square roots. So these are kind of cool. I kind of enjoy these. So we're going to go from expressions where we were at before, and now we're going to have those equations. And remember, we solve equations. And we do that by using all of those rules that we kind of remember, those multiply and adding inverses and trying to get to variables. And our main goal, excuse me, is to isolate our variables. Isolate our variables. Well, looking at that square again, say I have a square. And say I know that all of my sides are the same, because in order for it to be a square, every side of it needs to be equal. But instead of knowing the sides originally, I only know the total area. And in this case, I know that the area is 25 square inches. And I could ask myself, what is the side length? And I could go and remember, okay, I remember the formula for squares. Formula for squares says A equals side squared. Okay, so let me plug in. I have A is 25 equals side squared. And I need to isolate my S. And right now my S is squared. So I don't know what to do. Well, we can use these radicals that we've been talking about. And that's a really easy way to get rid of this squared. Because what I can do is all I have to do is I'm going to rewrite it again. 25 equals s squared. And what I can do is I can take the square root of s squared. And then those things will cancel out. Because if I take the square root of something that just got squared, all it ends up with is s. I've isolated it. But if I do something to this side of the equation, I do have to do it to both sides of the equation. So now I'm going to take the square root of this side as well. And we know how to find the square root of 25 because we've been practicing that. And I know that the area or the side length is 5. Now, in this case, this is true because it's involving geometry. So I only have one answer. But that isn't always the case. Because look what happens if I look at it from a purely algebraic expression instead of thinking about actual measurements. Say I have the equation that looks like this. And it says 49 equals x squared. Okay, well, this is easy. We should probably be screaming out. Whenever you see a 49, you should just see 777 in your head anyway, right? So to solve this, I'm going to do exactly what I did before. And I'm going to take 49 equals x squared. I'm just rewriting it so that I have more space. And I'm going to take the square root of both sides. That gives me x on this side. And it gives me 7 on this side, but it also gives me another answer. I have two numbers that I can put in to get x in this case. There are two numbers that I can enter into this original equation and have it end up as 49. 7 is one of them. The other one is negative 7. Negative 7 also satisfies the requirements because if I put negative 7 into this squared, negative 7 times negative 7, negative times negative is a positive, equals 49. So what's interesting is whenever I start with a squared number and I work backwards to get to what I originally started with, I'll always have two roots. Unless I'm, of course, talking about geometry. And in that case, a negative 5 measurement doesn't make sense. But when I'm talking about math, I will have this. So what I'll write instead of 7 equals x, or I could write it like this, negative 7 equals x. But the way that I write it to be most simple is I write plus or minus 7 equals x. And that means positive 7 and negative 7 will both satisfy the requirements. And this is going to start a whole nother section of math as you continue onward, where some problems will have two answers, Some will have 3 answers. Some will have answers in complete ranges. And it gets kind of trickier and trickier as we go. So I want you to do a couple of these, or watch me do a couple of examples, because they're different and they're like nothing we've done before. Let's take a look at another example. Okay, in this case, let me find one that I like real quick. Okay. This one says, we're going to go with, no, I don't like that one either. Okay, x squared plus 5 equals 14. All right. So in this case, I'm not going to start the way that I started last time. I'm not going to take the radical of both sides, because if I do that, I have to take the radical of the entirety of both sides. And that would look like this. X squared plus 5 equals 14. And I would take the entire radical of both sides like this. And I have no way to simplify this x squared plus 5 currently in my math knowledge. And the square root of 14 is going to give me a giant decimal number. And it's going to be very, very unhelpful and very difficult to get to the correct answer that way. So I'm not going to go that route. Instead, I'm going to attempt to isolate my variable as much as possible before I do any more work with it. So I'm going to get rid of this guy first. So to do that, I'm going to use my algebra skills, and I'm going to go x squared plus 5 minus 5 equals 14 minus 5. So to do that, I just subtracted 5 from both sides. And to simplify, I'm going to get x squared equals 9. Okay, now I can do exactly what I was going to do before, and this should scream out at me, perfect square, perfect square. So now I should know what to do. I'm going to take the radical of both sides. And that's going to give me x on one side. And it's going to give me 3, but not just 3. It's going to give me plus or minus 3. Because I can use positive or negative 3 to satisfy my original equation. And that is key. One last one that they're going to ask you, and it looks like this. And it has an entirely different way to solve. Example 2. This one looks like this. Square root of y minus 1 equals 8. Oops. All right. Now, what's interesting about this is just like we used a radical to undo a squared, we can actually do a squared to undo a radical. And in this case, it will work. So watch kind of what happens and see how this goes. I'm going to take this whole side and this whole side, and I'm going to square both of them, which is really, really cool. So on this side over here, I'm going to end up with 8 squared, which is 64. And on this side, the square root of y minus 1 squared, all it does is cancel out. So I can cross out my squared and I can cross out my radical. So it's going to give me y minus 1. And I have y minus 1 equals 64. Well, now I can just use simple algebra to solve this. I'm just going to add 1 to both sides. And I have y equals 65. Not too bad. So the key is when we start with a radical like this, you need to square both sides to undo it to get to our answer. And also what's interesting, and in this case, we don't have a plus or minus, because only 65 will be able to fit back into this equation and make it work. Negative 65 will not work. So it is important to keep that in mind. That is all that I have. And I think that should be enough examples. If you're still confused, please ask me, and I will... actually, I'll do a couple more, but if you feel like you get it, go ahead and go on. I'll even do some from the homework if you're sticking around. Example 3, which is, let's do number 8 from the homework. Number 8 says x squared minus 5 equals 20. All right, to solve this one, all I'm going to do is I'm going to add 5 to both sides because I need to isolate my variables before I can do any kind of squaring or square rooting. So I'm going to do x squared minus 5 plus 5. And this plus 5 is what's undoing my negative 5, right? 20 plus 5. Okay, these cancel off, and I have x squared equals 25. Okay, so I'm going to take the radical of both sides, take the square root, and I have x equals 5, but not just 5, plus or minus 5, because either of those will satisfy that if I go the other direction. And there I go. Let's take a look at one more. Looks like we have a couple cube roots in here, which is kind of interesting. They are throwing us for a spin. Example 4. Let's take a look at number 14. In this case, we have x to the third power equals 8. And in this case, we're going to take the cube root of both sides, just like we took the square root before. The cube root kind of looks like this. And we cancel out, and we have x equals. And in this case, the cube root of 8 is what times itself twice gets us 8. And the answer to this is 2. What's interesting, though, here is it is only 2, because when we take cube roots, we do not get 2 answers. We only get 1 answer in this case. So, because if I put negative 2 inside, negative 2 times negative 2 times negative 2 equals negative 8, because a negative times a negative times a negative is a negative. So in this case, it doesn't work, which is kind of interesting. So in this case, our answer is x equals 2. And I'll do that last one as well, number 15, just in case you get stuck. That is x cubed plus 4, x cubed plus 4 equals 31. Okay, I'm going to get rid of that 4, minus 4 to both sides. I have x cubed equals 26. Now, I don't know my cube roots very well. I'm going to guess that that is 3 or 4, because cube roots grow crazy fast. 3 would be 3 times 3 times 3, which is 27. That makes me think I did my math wrong, and I definitely did. This should be x cubed equals 27. So that would give me, if I take the cube root of both sides, I have x equals, what times itself 3 times is 27. 3 is, and I have 3 as my answer. All right? Hopefully that works, and I hope you've stuck around. Good luck.